Hello, we are Group 6 presenting our project on Guided Interactive Database Dashboard. So this is our outline. We'll briefly talk about the problem we try to address, then give you a quick recap of what we've done, show you our new progress we've made recently and explain why and how, and then lastly, summarize the lesson and takeaways from our project. So what is the problem we try to address? As we mentioned in the midterm video, some key challenges we are facing includes the complexity of data analysis, lack of data literacy, difficulty in data visualization, and data integration. So many data sets are large and complex, making it very challenging for users to effectively analyze and derive insights. And a lot of times, users don't have the necessary skills and expertise to effectively perform data analysis. So creating meaningful real-time visualization is crucial for conveying insights from data. And let's not forget, data are often scattered across diverse data sources and systems, which is adding another layer of complexity to the equation. So our guided interactive database dashboard is designed to address all these challenges. Now let's see a practical example to give you a sensible idea of the challenges we faced. So we want to have interactive analysis for traumatic brain injury module data from Ohio Behavioral Risk Factor Surveillance System. So for a typical data file like CSV, the size is 37.4 megabytes, which contains about 16,500 records and close to 600 attributes. Besides this large data file, there are multiple long codebook reports that explains the types of labels and the meaning of their possible values. And that's not the end. There are quite a few other files. For instance, another file called complex sampling weights tell you how to deal with weighting procedures. And a super long questionnaire, which is 213 pages, includes tons of screening and medical history. And there is another layout file which explains how to go through this questionnaire and in what kind of order. Okay, now let's quickly recap what we did before the midterm. So we set up DuckDB as the backend database and integrate it with the Django ORM for data manipulation. To handle large dataset efficiently, we utilize a patch arrow for serialization and deserialization of data streams between server and client. Our responsive front-end dashboard layout integrates several components, such as SQL editor, functional sidebar, and the visualization area. In the SQL editor, user can write and execute SQL queries prompted by LLM. We designed the visualization area to display the SQL query results in table and all kinds of data visualizations. So Perspective library was integrated into our dashboard to render SQL query results, such as bar chart, pie chart, and other more complicated ones, with features like sorting, filtering, and aggregation. So we also implemented a file upload feature to allow users to upload CSV and database files.
Okay, after the main point, we first tried to containerize our Django backend. We made a Docker file and upload our Docker to the Docker Hub. The front-end website is hosted on the Netlify, so user can access that website and click for this switch in the corner to run his backend in local or in the cloud. And also, since we containerized the backend, so it is easy for user to scale up and down on their own cloud service very safely. And we also tried to transition to Vega for visualization, because the Vega has a more concise and declarative JSON syntax, which provides more freedom to customize than the Perspective JS, and easy for large language model to automate this process. And also, we tried our Canvas implementation. We actually do make some simple individual Canvas cards like visualization cards, SQL editors, and file uploaders. But we finally abandoned that because the main reason to consider Canvas is for this flexibility to visualization generation and display. But however, we didn't implement Vega visualization yet, so there is no visualization pop out. We also try to integrate with ALM, and first we try to use lemma and vector stores. We use Mistral on lemma and try several vector DBs like those things, but they are all pretty bad and unstable for their results. So then we switch to the OpenAI's API, and it is far more easy to use, and the result is pretty good. We choose GPT 3.5 for our use and enable OpenAI's retrieval tools here. And this is an example of one assistant. You can attach a file here, and you can also attach your files along with your message. These tools are different. We choose to attach a description file for each thread. A thread is like an assistant, and attach data set files with each message. We make a different class for each assistant, and the global instructions is attached to one class. And we also upload description files to that thread. The description file is looked like this. We list the labels and the description of the labels and its label name. Notice that the label descriptions can be very bad. For example, here is some missing space, and this kind of strings cannot be understood by the lemma and several vector DBs. More detailedly, we'll first make an agent to understand that dataset. So once you upload these description files to the dashboard, you can select this line, and this line is just a question sent to the LLM, like these questions. And once you select this and press Ctrl Enter, it will send this question to the backend and route this to the LLM. And once you get the result, it will print the results in the LLM log here. And this one is from the GPT-4, and this one is from the GPT 3.5. And both two understand the dataset pretty good, and both ask some variable questions. So next, we may want to let LLM to give us some suggestions. So we make another agent and use this as a part of the global instructions, global prompt. Then we select this line and ask the LLM how does income related to health, and it will list some related labels here. And here I tested on the GPT-4, and it can also generate some SQL queries. And below that, it also give us some visualization recommendations like a bar chart and a pie chart. The first is a bar chart, so I choose the bar chart here. So this is the next step. After I choose the labels and get the SQL queries and get the visualization type, we can let the LLM to generate a Vega JSON file like this and make a visualization like this, but it is not implemented yet, so this Vega Lite file is not tested. And this image here is generated by the perspective.js, and the dataset is from this query. So I just select this and press Ctrl Enter, and it will show the result in this format. So why we need separate agents? Because when I tested this process, I found that we sometimes need independent contexts or histories and independent instructions or global prompt. And each agent may need to go through many small steps or in charge of different functions. In the future, the whole process may like this. We upload that file to the dashboard, and one agent will in charge of understand this and understand the whole dataset and give us some insights and valuable questions like we listed before. And second, we can go to several action suggestions robots, and it may suggest some SQL queries or visualization types or some Vega JSON pieces, and all those pieces combined into our final process to generate a Vega JSON. And this JSON can answer questions like how does the income related to health. Okay, one sentence is we have almost developed a scalable and safe database system that help users to understand their dataset and quickly start questioning and create visualizations. And finally, although OpenAI is closed, it do save a lot of time for me. Thanks.